Welcome, everyone. We will begin the webinar on BASF, Improving Cycle Time with UV Curing. I'm Melissa Joles with RDA Impact. Brian Dean, Product Manager for Clear Coats and Undercoats. David Braun, Research Specialist. Bill Berry, Application Manager for North America. And Alan Lukens, Global Business Solutions Manager from BASF Automotive are your presenters today. The presentation will take approximately 45 minutes. We are recording it and will post it on our YouTube channel. If you have questions during the webinar, you can type them in the chat box at the bottom right of your screen, and they will answer them during the presentation. Now, I'll turn it over to Brian.
Thanks, Melissa. And thanks, everyone, for joining today. I just wanted to say a big thank you on behalf of BASF for taking time out of your busy schedules to join us today to talk and learn a little bit more about UV primers and how it can, really help out not only yourselves from a distributor perspective, but also your end customers from a body shop perspective. So with that said, let's go into the next slide here. So just going a little bit further on the introductions, obviously you can see our beautiful faces at the top on video here, but we wanted to put at least a photo to the name. So I myself, Brian Dean, the one who's speaking right now, I am the product manager in North America, handling all of our clear coat and undercoat technologies. Dave Braun, who's joined us, who's on video as well, is one of our research specialists. He works specifically in our development labs. He has developed several primers over the years, so we welcome his expertise. Third is Bill Berry, which he'll be joining us if he's not already on the call. He is our application manager for North America. They do a lot of the different testing before our products go to market, and as things come up while products are in the market in terms of testing the actual products. And then third is, fourth is Alan Lukens, who's also on video there. He is our Global Business Solutions Manager. So I won't pretend to go into detail as to what that all entails, but we're glad to have Alan join us today. So each one of us will be running through various different topics. And with that said, let's go through a quick agenda here. So we're going to open up with the various types of undercoat technology. Of course, today the focus is going to be on UV, but before we delve into that, we want to be able to go through just at a high level some of the other technologies that several of you are probably already aware of, but we just want to be able to set the tone for the discussion today. Next, we're going to be talking about how UV is different. So what is it about UV that sets itself apart from the different various primer options? And then going deeper into UV, we want to talk about the various curing options that are out there in the marketplace today and that are available for use out in the field. Next is we're going to be talking about the best practices in terms of UV. So in terms of actually applying UV and the different practices that users should be following. And then next, we're going to delve more into the process and the cycle time benefits. So if you're pushing UV or if a customer is already actively using UV technology, we'll go into what's in it for them, right? So not only in terms of cycle time benefits, but there's also going to be capacity and revenue opportunities when using UV as opposed to other technologies out there. So after that, we'll close with a short summary and then we'll open it up for Q&A at the end. I will say, and Melissa, maybe you can chime in, I think there's a chat box if there's questions as they come up during the presentation, and feel free to add them as we go here and we'll answer them as they come in. Is that accurate?
Yes.
Okay, very good. So just a high-level overview here, and this should be no surprise to anyone, about the different layers of the paint process, I guess, if you will, of the paint layers on a car. So going from the top to the bottom, I mean, we think about the very top layer, the shiny layer, which is the clear coat. Oftentimes with a refinish repair, we're trying to duplicate that finish and gloss level in terms of what the rest of the car is from the OEM, from the plants, right? So not only that, the clear coat is there to protect itself against the environment. So that way, over time, there's not deterioration and breakdown of the coating layer. Underneath the clear coat is obviously the base coat. So this is what gives the color to the car. We're trying to, just like the clear coat, replicate the color in this instance to the rest of the car when doing a repair. And then if you're not doing a repair and it's more of a project or a bodybuilder type of thing, that's where you're really going to have your personalization as to what type of color you want the car to look like or what texture or so forth. But of course, none of this is possible without having a solid foundation, right? So we think about undercoats, which is what we're going to be talking about in specific today, are really that solid foundation to be able to really set the tone for a great repair, right? So with undercoats, we think about having corrosion protection, good substrate adhesion, and then as well as filling imperfections, because we all know out there that the parts that come in from various manufacturers are often delivered with imperfections in them, and or if there was an accident that needs to be repaired, right? So every good repair starts off with that solid foundation of a great undercoat. So I wanted to lay out here just a quick visual, and this is again very high level, and it's going to be in more typical various different primers. So of course there's going to be exceptions. I understand that, but I wanted to at least at a very high level what was most typical. So if we think about the various primer types, and again, these are just some of the high level different primers. We have epoxy, we have etch primer, we have 2K urethane, and then of course, as we're going to talk about today, UV primer. So going into epoxy, I mean, the typical repair type for epoxy primers is going to be your large bare metal surfaces. Generally speaking, when you're using epoxy, you're going to have slower cure times. And in terms of the curing capabilities for epoxy, you have air drying, baking, or infrared technology to be able to cure that primer. So in terms of some of the top attributes for epoxy primer, obviously it has great corrosion resistance. It promotes adhesion. More times than not, it's going to be direct to metal, and you're able to top coat directly over it, so no layer between the epoxy and the top coat. And then one thing to note, there really is probably mixing required more times than not with epoxy. So going into etch, this is going to be more of the primer that would be of choice if you're going to be doing a spot repair. And the reason behind that is because it's got a very fast cure time. In fact, more times than not, it does not require anything but just letting it air dry. So like any primer, it provides corrosion resistance. It's direct to metal. The thing is with etch though, is you cannot directly top coat over it. There's usually a separate layer between that and the base coat. And then with etch as well, unless it's an aerosol, there's typically mixing required. So going next down the list here, we have the 2K urethane. So this, is probably the most popular out there for everyday use. Your 2K urethane is going to be used multi-use, whether it's on plastic or metal. The cure time, generally speaking, is medium, and there are various different types of curing capabilities. So you have your air dry, your baking, or your infrared technologies. With 2K urethane, it can be direct to metal. You can top coat directly over it, which is a huge plus. And then with 2K urethanes, you do have to mix. Now, with the UV primer, the great thing about it is, yes, it's multi-use just like the 2K. Depending on which curing type you use, it's going to be a lot faster than any other primer. So the curing capabilities are much different with the UV primer. So you can use, of course, just regular sunlight, but the quicker options would be to use the various technologies on the market today in terms of standard UV and your LED lamps. And Bill, later in the presentation here, will delve a little bit more into that. With the UV primer, it can be direct to metal. You can top coat directly over it, which is a huge plus. And then I guess the part that sets it apart from all the rest is that it's very easy to use. So UV primers are ready for use, meaning you do not have to mix it with any other components. So it's ready to use, and there's not a lot of waste or anything like that. So with that said, that's just a high level overview, like I stated, and with that, we'll go next over to Bill.
Okay, guys. So we're going to talk now just quickly about some product attributes. What about UV makes it special and unique? So as Brian just mentioned, it's 1K. Product is typically ready for use, so no mixing is required. One of the key things about UV primer is that it's transparent, and it needs to be transparent in order to allow the UV light to cure it fully. And we'll cover this a little bit more later in the presentation. We talk about some application tips and some tips and tricks to make sure you're successful with it. Most UV primers are direct to metal, and they're suitable for basically all substrates that are you'll encounter in the refinish industry with proper preparation. They have an exceptionally high solid content, and this is one of the reasons why, again, later in the presentation, we'll get into you need to select the proper application equipment to apply them effectively. But also this exceptionally high solid content versus conventional 2K urethane primers means that the primer builds much faster, and more of the liquid primer that gets sprayed onto the vehicle ends up as dry usable film. And so that's why UV primers are typically packaged in smaller quantities, and you won't consume as much liquid material as you will with a conventional 2K urethane. UV primer cures in either artificial or natural UV light with the proper intensity. Again, we'll go into this a little bit more about when we get talking about the lights, but most UV primers will cure in natural sunlight as well as utilizing lamps. However, natural sunlight is not the preferred method of curing just because it's disruptive to the process in general. There's no lingering evaporative solvents in UV primer. Once it's cured, it is cured, and so we don't have the impact of those solvents that are typically in conventional urethane primers having a negative impact on the gloss retention of the clear coat over time. So this prevents any dieback and long-term gloss loss. And then tied to that, again, UV primer is 100% cured after proper UV exposure. So this means it will never move, it will never shrink. As long as it's well cured, it is going to stay that way for the life of the repair. And that has a huge benefit because it prevents any ringing or any edge swelling of that repair area later on, which you can sometimes see with urethane primers, especially if they're under cured. So, and the other nice benefit about UV primer is it's compliant across North America. So in any market in North America, you can utilize UV primer. Yeah. So from there, we want to talk about lights a little bit and curing technology. So UV primer, we have a ton of options out there for lights these days. In the last couple of years, the market has really expanded and exploded with all kinds of UV lights that are out there and available. And we want to hopefully provide you with a little bit of insight here as to what directions you should go and how you need to select lights for your customers. So with that, you have to look at the type of repairs that your customer is looking at utilizing UV primer for. A lot of times, initially when they're trying UV primer out, it's for smaller repairs and initially getting used to the product. And so in those scenarios, lower cost LED handheld UV lights make a lot of sense because they are reasonably affordable and they're really designed for those smaller spot repairs that will be utilized, that the primer will be utilized for. As their customer expands and becomes more interested in utilizing UV primer in all types of repairs, there's another larger decision that they need to make about the type of light that they're going to go with. Whether it's a stationary light or a handheld high-powered unit. The advantage stationary lights have, especially some of the ones that are offered from IRT, is that they combine IR curing as well. So you can utilize them to cure your the body filler with the IR and then just switch on the UV to cure your UV primer. And as well, stationary lights allow the operator to walk away and not have to manipulate the handheld light over top of the repair area or hold a light over the repair area. And that helps ensure that they get a good proper cure time too as well. And additionally, most of them have timers built in to make sure that you hit that right cure time. The advantage of some of the higher powered handheld lights are that you can more quickly get through the repair. So yes, it requires the operator to manipulate the light manually, but it may only take them 30 to 40 seconds to cure a very large area compared to a stationary light, which would have to be parked over the repair area for at least 5 minutes. So the handheld lights, the high-powered handheld lights, give them a lot of flexibility to do small or large jobs, and it also can minimize accidental exposure to other people in the shop because the handheld light is out of its cradle and on and emitting UV light for a much shorter period of time than a stationary light, which is parked and constantly putting out that energy, which can be potentially harmful to people walking by in the shop. Yep. So Alan, if you want to go to the next slide. So one of the key things to understand about the technology, and this is important for you to understand what kind of lights you should recommend for our customers, and you know what kind of lights make sense to purchase for what type of repairs. This is a graph of light wavelengths, and basically what this is showing is that UV mercury lamps emit UV energy over a wide range of wavelengths, whereas UV LEDs emit light in a very specific wavelength. And this also points to the importance of making sure that whatever UV primer that you're using, the light that you're using with it has been approved by the manufacturer of the UV primer. Especially with LEDs, because LEDs have very specific wavelength emittance, and it's very important that that is in the right range to effectively cure the UV primer. So, that's kind of the difference when you look at, UV LEDs, and why you probably should make sure that you purchase an LED light that's been approved by the paint manufacturer, as opposed to just picking up any UV light that you can find on Amazon or at Home Depot. Yeah. So some really important safety and health precautions. UV LED or UV energy, whether it's from an LED light or a mercury lamp, is dangerous, and all spectrums of UV light are dangerous. UVA is one of the major contributors to skin cancer. So it's pretty important that when your customers are using UV primer, that we're focused on safety, and that we provide a good message about how to protect yourself when using the UV lights. So this is just some general guidelines that we put together to recommend as BASF for our customers. Generally 3 foot in any direction away from the light. You should cover all of your exposed skin. This means wearing a lab coat, gloves, and some kind of face shield to protect your face from the UV light, as well as wearing UV rated eye protection. Obviously, if you're wearing a face shield, you should be okay there. And then outside into that 15-foot radius, so between 3 feet away and 15 feet away, anybody in that area should be wearing UV rated eye protection. And additionally, one of the ways that you can contain this in the shop is with welding screens or curtains. Most prep deck curtains work pretty well for this. Even the ones that are transparent, you can get inserts made for them that protect against UV light. So yeah, it's really important that we make sure that we recommend good PPE and proper processes there in the shops, so that everyone's safe and protected. This can be a particular hazard when you have somebody who's unfamiliar with your shop as well, walking through the back area. You need to make sure that that UV curing area is well contained, so that somebody doesn't accidentally get exposed to light. Yep. Okay, so UV primer does require some different specific processes in order for you to be successful in applying it and using it. One of the big important things to remember is that UV primer is light sensitive. It's cured by UV light, but that also means just the lights in the shop can cause it to cure slowly over time, and can cause seeding and other issues. So it's really important that that the primer is kept away from light when it's being stored. And it also is important that it's agitated well. UV primers require agitation or mixing or shaking on a regular basis in order to prevent settling, and to make sure that they're usable and sprayable. From a spray gun and cup perspective, we used to recommend mini jets or touch-up guns for UV primer. Nowadays, most gun manufacturers have UV primer specific primer guns or setups for their primer guns. And those are really the setups that you should be using for UV primer. They're smaller fluid tips, 1.1, 1.2 fluid tip sizes, and this is just due to the lower viscosity and like we mentioned earlier, that higher solids content. You don't need to apply as much wet film to get the same dry film. So it's really important that we maintain, or that you use the right spray gun and tip size. One of the quickest ways to fail with UV primer is to use that wrong spray gun setup, because you will overbuild the primer and your transparency won't be there and it won't cure well. So starting with a proper spray gun for UV primer is really important. As well, there are paint cups from all the major disposable cup manufacturers that do not transmit UV light. This is pretty important as well, so that as the gun sits throughout the day with the UV primer in it. Because it's a 1K product, it can do that. But as it sits throughout the day, you're not curing primer in that cup and causing potential contamination in your work. So pretty important to make sure that you've got the right spray gun and cup equipment. Another key thing to be successful is to ensure that you have good surface preparation. UV primers typically need really good mechanical adhesion and proper sand scratches. This is because as they cure, they shrink rapidly and they need good sand scratches to grab onto in order to get good adhesion. So those sand scratches are really critical. So following the TDS for each UV primer is really important for prep. As well, some UV primers do require special pre-treatments in order to work well. So just make sure that you're really respecting and following the tech data sheets when you're working with UV primers when it comes to surface preparation. And then application technique, again, you should really take the time and not just hand UV primer to someone who's used to spraying 2K urethane primer. You really have to go through and explain and ideally demonstrate that the film builds very rapidly, and that in most cases 1 or 2 coats provides the same amount of film build as 2 to 3 coats of a 2K urethane primer. And so being very careful to avoid overbuilding the primer. That's the most common failure for UV primer that we see in terms of application, is too much application, too much primer on the target. And there's a really quick and simple guide for you visually as you're applying the primer. And that's simply, it must be transparent. So if you cannot see the bodywork, if you cannot see the repair through the primer, you might as well rinse the primer off and start over with another application, because that primer is never going to cure well against the substrate. And you have to think of it as, why do you need that transparency? And a great way to explain it is that primer needs to cure all the way down. And the most important layer where your adhesion is taking place is right against the substrate. It's that last layer. And if the light can't reach that last layer and cure it, you have no adhesion then. And you'll see this failure as, when you're using it and sanding it, you'll feather edge away from the edge of the repair. And as you get into where the meat of the primer is, where it's overbuilt, it'll pop off and fall off the repair. So lack of adhesion a lot of times is due to insufficient curing, which can be due to lights. It can also be due to not being transparent enough. And so that's really critical from an application perspective for being successful with UV primer. It's just maintaining that transparency. A great tool to have with you when you're doing demonstrations and training people on UV primer is a mil gauge, and taking mil measurements before and after curing, and showing that, yes, even though it's transparent, I still have 3, 4, 5 mils of primer on here, is a great tool to use for a demonstration. And another thing, another important part in the application process is remembering to observe your proper flash times. UV primers they do have solvents in them. They're very fast solvents, but they do have those solvents in them in order for the primer to spray well and flow out onto the panel and create a nice film. Those solvents need to get out of that film before they are cured. If the primer is cured but without observing those proper flash times, you'll end up with a lot of pinholes and solvent pop marks as you're sanding through the primer. So observing those flash times is really important in order to ensure that you get a good final result with the product.
All right, so now that we've talked a little bit about the different types of undercoats we have, talked about the benefits of UV in terms of the product attributes, how to properly use it and protect yourself against it. How does this help turn into tangible improvements for a collision center, right? So as we know in today's world, it's all about cycle time. It's all about, how do I do the repair, do it properly, and do it one time so that the customers get the car back properly and in the time that was promised by the collision center in the shop, right? So when we look at conventional high performing urethane primers, you've got up to 8 SKUs if you're looking at multiple gray shades, if you're looking at multiple hardeners, multiple reducers. You've got to spend time mixing those. Once you mix them, because they have a hardener, you have a limited pot life in which you have to use that. You may or may not require an etcher primer or some sort of adhesion with an epoxy. Cure times can range all over the board based upon, whether you're using IR or if you're in cold temperatures and it's extended with an air dry capability. And then they're not cured for up to 90 days. So you have the risk of the substrate either impacting the gloss, as we mentioned, of the clear coat earlier, or having some potential for shrinkage, right? And then throughout the application process, you've got your apply and your flash and apply and flash, and then you've got to air dry or bake. And while you're air drying or baking, you have this waiting game, right? So it's dead time where you're not being productive. Yes, you can work on other vehicles, but as we know, in terms of cycle time and touch time, you want to be working on that one vehicle, start on it, get it done, and move on to the next one to be most efficient in the shop, right? But when we look at UV primer, we mentioned it's ready to use right out of the gate. So it's typically you put it in the gun, you can leave it in there with the cups that are not transparent to any light permeation. There's no waste. So when you use it, you apply it, you're applying that 1 to 2 coat with the proper tip size, and you're not having any leftover product that is going to catalyze or you have to dump out or recycle. It's often direct to metal. A coat and a half is typically sufficient given most of the different products out there. They're fully cured in artificial natural sunlight. But at the end of the day, it's all about the reduction in the SKUs and the reduction in the application and flash times and the cure time to be able to get to sand. So from the time of pouring it to sanding it is typically under 10 minutes, right? So that frees up an additional almost 30 minutes in capacity per vehicle, which is 4 times more productive than conventional urethane primers. And that's when you're using the latest and greatest UV technology with the proper intensity to cure that product, right? So don't waste your precious cycle time waiting for things or applying products more than technology has risen to bring you to another level, right? So what does that mean for a shop in terms of that extra 30 minutes per vehicle? So just for round numbers sake, we took and said, okay, let's look at a shop that's got around $1 million in annual revenue, right? So if we look at, they've got a average RO of $3,000. We know there's approximately 221 working days in a year, 8 hours a day. Let's assume a good performing shop's around 40% gross and 10% net profit, right? So that 30-minute is really applicable because that gives them an extra 45 minutes per day. I mean, again, this is per $1 million in revenue, which translates into an extra 13.8 hours in production labor capacity and almost 165 hours per year. So that's tangible. We can start to turn that into production capacity. That's almost 19% that you can free up in your capacity. Another 0.3, you can't do in increments of part of a car, but you can certainly start on a car if you're doing multiple $1 million in revenue. For a $3 million shop, that's an extra car a day. So that's an extra $3,000 a day in revenue potential given that extra vehicle. Translate that into sales capacity. So almost another 22%, $900 a day, $4,200 a week, but $220,000 a year is added sales capacity given those vehicles more produced per day, right? And at the end of the day, we turn that into gross profit, right? So what is the shop is we're assuming here, a round number of 40%, but if the shop has greater gross profit potential, it means they're putting more revenue back into the business, right? Before their fixed cost. And then after their fixed cost, it's all about net profit. What can they reinvest into the business tangibly or possibly put into the bank? So without doing anything other than changing a few processes and swapping out some SKUs, they're increasing their net profit potential. And when you look at, for this $1 million shop, potential of 9K of net profit, that can help reinvest or even pay for the investments you might need in curing technology, right? So the larger you scale, the more net profit you'll be able to generate, the faster the ROI is going to be for the shop. So you can have typically a very quick ROI for the shop in terms of what level of investment they need to make for the curing and the productivity demands that they might have. So if this shop is doing a car and a half a day, they might not need a lamp that cures the product in 20 seconds. They might need one that cures in 2 to 3 minutes, right? So it's relative. So the ROI is relative to their production and their ability to meet that and fill that capacity. So when we look at it, the benefits are pretty transparent and clear, right? Kind of like the product. In terms of time, there's really no mixing. There's a reduced application and cure time, increased labor and productivity and technician efficiency. When we look at production, our shops can do more vehicles with the same amount of resources that they have today. Improve their touch times and cycle time, which will make all of their network partners, and their customers very happy. Looking at the revenue, lower SKUs, less inventory stocked on their shelves, no product waste. So every penny is getting put on the car and is staying there. With the exception of what gets sanded off, it's not evaporating. Additional revenue and profit opportunities. And then at the end of the day, it's about customer satisfaction. We see the customers getting their vehicle completed faster, so you're more likely to deliver the car on time on that given promise date if you don't have any interruptions, right? So we know that delivering on time and kept informed and all that impacts customer satisfaction. And at the end of the day, that job is going to look better for a longer duration given the fully cured nature of the product. So that, Brian, I'll hand it back over to you.
Thanks. So yeah, again, I just wanted to say thank you for everyone that took time out of their day to come learn a little bit more about UV. Thanks, Bill and Alan, for the overview. And throughout the presentation here, I've been kind of taking a look. I didn't see anything coming through the chat. But I don't know what you do at this point in time, Melissa, if we want to open it up or if anyone has any questions, feel free to type it into the chat. And we have 4 different resources here that are more than willing and happy to answer any questions that anyone might have or had thought of throughout the presentation.
Sure. Yeah. If anybody has questions, feel free to ask, and here we go. Can you read that? You want me to read it to you?
I cannot read it.
Is the Glasurit UV primer now okay to go DTM? Is that misspelled, or I'm not sure? It's GLASURIT, UV primer.
So I think the question was, is Glasurit UV primer direct to metal?
Yes.
Yeah, I mean, the Glasurit UV primer is direct to metal, yes.
Anyone else have questions? And I will follow up by sending Brian's contact information out. He can follow up. So if you do have, we can reach out to your local representative. And we did record it, so we'll send the recording out to everybody. It'll be available on our YouTube channel as well. I don't see any other questions. Okay, well, with that, we do appreciate everyone from BASF coming out and doing this presentation. It was excellent, and we'll be in touch with future training opportunities. Don't forget to subscribe to our YouTube channel for past webinars, and we appreciate your comments and your thumbs up if you like it. Thank you. Take care, everyone.
Thank you. Have a great day, everyone.